Okay, Assalamu alaikum. Welcome to lecture 3 of data mining. So we conducted a poll over the weekend. In that poll, we asked you regarding whether you would prefer an online delivery of the lecture or in class. So the close were relatively close, not I was expecting to be much wider. So 51% of you said that you wanted or you preferred an online delivery, and 41% said that you want it on campus in the classroom, and I think about 5-6% were indifferent. So actually the online people actually won, so we are having this lecture online today. So so during the online lectures, if you have any questions, you can either speak out, or you can even send a message. The message can be short, and but you can also speak up out. And if you have something to say, you can raise your hand as well. So there are all of these three options available to you. You can speak out. I think that is preferred if you want to stop me, and you can raise your hands, or you can even send a message. So I will be able to see all three, and hopefully will be able to respond to your question. So are there any questions or comments before I get started? ठीक है, तो मेरी आवाज आ रही है ना सबको?
Yes, sir.
जी ठीक है, तो ठीक है, so let's then get started. Is my screen visible?
Yes.
ठीक है, so just a second. All right, so in the last lecture, we had started talking about exploratory data analysis, and we had started talking about the types of data, their representations, and then we also started talking about some basic stats for determining the central tendency as well as determining the spread tendency for individual attributes. And then later on, we will also discuss trying to determine characteristic regarding pairs of attributes. So I will quickly refresh the types of attributes again. In general, there are two broad categories of attributes. We have categorical and we have numerical, right? So within categorical, we have two further distinctions. We have what is known as ordinal, or let me start with nominal, and then we have ordinal. So nominal attributes do not have any order among the labels that are assigned to that attribute, while ordinal attributes do have an order, predefined order among the labels that are assigned to that particular categorical attribute. Another common example of categorical is binary attributes. So binary attribute is a categorical attribute that has just two values. And so usually they can be 1 and 0. Of course, 1 and 0 are labels, they are not numbers. So this is something that you need to be careful about. And Among the binary attributes, we sometimes also distinguish between symmetric, uh, symmetric and asymmetric. Okay. So the distinction between the two is that in symmetric, both of the values are considered to be uh, important for the application. While in asymmetric, one of those values is considered more important than the other. And the typical example is given is, for example, a medical test result. Uh, is my typing visible to you?
Yes, sir. Yes, sir.
Yeah. Okay. So test result. So for example, if you take a corona test, for example, or COVID test, if you are positive, that value, so there are two possible values, a positive value and a negative value. Generally, the positive value considered more significant in analysis as compared to the negative values. And in general, for any medical test, for any population, the number of people getting positive would be much, much less than those getting negative. So that's why that positive value considered more important than negative values. For such attributes, we call such binary attributes asymmetric. Okay, so going forward to numeric attributes. So these have two subcategories as well. We have what is known as interval scaled, and then we have ratio scaled. So interval scaled are numeric values uh, which do not have an absolute zero. So these values are relative to one another. Uh, while ratio scaled attributes are those that have an absolute zero, meaning that a zero value signifies an absence of that particular attribute. So the typical example that is given here is from temperature. So temperature in, for example, Celsius and Kelvin, for example. So Celsius, when you have 0 degrees Celsius, this does not mean an absence of temperature. So as such, Celsius is interval scale. It is numeric. It's interval scale. The difference between two values is significant. So 15 minus 10 is the same as minus 5 and minus 10. But you cannot take ratios because ratios will depend on absolute zero. So ratio scaled, on the other hand, in this case would be Kelvin. Kelvin, 0 Kelvin means absence of temperature. There is nothing less than that. Of course, it is interval scaled, but it is also differences do make sense as well as ratios. So most, you can say, scientific observations are ratio scaled. They have an absolute zero. So for example, you have age, you have weight, you have mass, you have so on. And many or most behavioral measurements are uh, interval scale. So for example, rankings or something like uh, small, if you talk about sizes, small, medium, and large. So clothing sizes, for example. So this would be, and of course, this is ordinal. These are labels actually. But let's say you give them numbers and you want to ensure that the difference between the numbers is the same. So for example, so let's say this is 1, this is 2, and this is 3, and you predefine that 1 and 2 difference is same as 2 and 3 difference, and 1 and 3 difference is twice the difference of 1 and 2. So it is interval scaled, but it is not ratio scaled, because a value of 0 does not mean absence of size. Okay. But of course, if you don't even want to assume that the difference between 1 and 2 is the same as 2 and 3, then this attribute would then become ordinal, categorical. These are then labels. Okay. So why is this all of this important? Because you need to then understand what type of analysis that you can do on them and what type of stats that you can apply on them. So, so if you consider this size to be ordinal categorical, then you cannot do numerical computation on 1, 2, and 3. They would be meaningless or they will be misleading. Okay. So any quick question here so far? Okay. Sometimes we also characterize attributes as discrete and continuous. You can do that, but I think categorical and numerical categorization is much better. Discrete essentially means that the set of values for that attribute is finite. Continuous essentially means that the set of possible values for that attribute is infinite, like numbers, floating point numbers, for example. Okay, so this distinction sometimes is also made. Okay, moving forward, we were discussing the central tendency as well as the spread tendency, and we had discussed main quantiles, quartiles, minimum, maximum, median, and so on. So there is a set of numbers that is quite important for a single attribute, which is called the 5-number summary. So this 5-number summary for any attribute is basically the min value, the Q1 value, the Q2 value, the Q3 value, and the max value. Okay. Uh, so these 5 numbers would summarize uh, an attribute's values in this way. Of course, since we are computing Q1, Q2, and Q3, the attribute must be uh, ordinal as a minimum. Remember, there's a ranking among the attributes. So nominal has the least information, ordinal has the next higher information. Then we have interval scale, which is next higher information. The most expressive attribute is ratio scaled. Okay. The ratio scale information attributes are the most expressive, most measures can be computed on them, while for nominal attributes, you will be able to compute only very few measures. And as I mentioned last time, so IQR is basically Q3 minus Q1. Okay. So interquartile range, this would give you an idea of the spread. And I think last time I mentioned 3 times IQR as a thumb rule for outliers. I think it is 1.5. So basically median plus 1.5 into IQR. If an attribute lies beyond this or is greater than this, then it can be considered as an outlier. On the flip side, median minus 1.5 into IQR would also be an outlier. Again, these are thumb rules. It's not like this will work all the time. You can always change this. This is a thumb rule that has been used and is given in the textbook as well. Okay, the 5-number summary can be represented as a box plot. Box plot is a visualization. So box plots, as you can see, has all those 5 values represented. So, so one box, there is a box. Let's say the y-axis is the value of the attribute. So there is a box. So there is a line below, which is Q1. Then there is a line in the middle, which is Q2. And the upper line of the box is Q3. So this box is the IQR, Q3 to Q1. And then there are lines from the edges of the box to the min below, and to the max above. And of course, you can do this on one plot. You can show multiple attributes. एक box एक attribute का, दूसरा box दूसरे attribute का, तीसरा तीसरे का, and so on. So this visualization is a box plot, quite useful visualization, very easy, and you can plot it using any plotting library in MATLAB, in R, and maybe even in Python, Maxplot, and so on. In this figure, and basically, it give you an idea of the spread as well. If you look at the box, if the median is, so let's say the median is here, and then you have the Q3, and then you have Q1 here. So this range is much higher, and this range is much lower. So you get right away, you know that there is much higher density here, and there's lesser density here. There is more values in this range from Q3 to Q1 because the spread is small, meaning let's say Q2 is, let's say, 50, Q3 is 55, while Q1 is 5. So there's a lot of spread there. So fewer, of course, in quartiles within each range, you have equal number of values. So the spread here is larger, the spread there is smaller. Density there is larger, density here is smaller. So you can understand the distribution as well to some extent. Okay, then we can plot histograms as well. So histograms are more detailed. You can develop intervals and plot the frequency, the count, as well as the frequency of the number of values in each plot. So histogram basically are bars. The height of the bar represents either the count or the frequency. When I say frequency, usually I mean the number of values divided by the total number of values ratio. And of course, each bar represents an interval, usually equi-width interval of the attribute of analysis. Again, you get a distribution and analysis, an idea of the spread of the data as well as the distribution of the data. For continuous or numeric attributes, you can also plot your standard statistical, for example, distribution, which we call the probability density function. So you can also do that. So for any numeric attribute, you can plot the probability density function. This value would give you the probability density. If you want to find the probability for any interval, so probability of, let's say, between values 5 less than equal to, let's say, x less than equal to, let's say, 20. So this would then be the area under the PDF between 5 and 20. Okay? So this is the probability that a value would lie between 5 and 20 if you have a PDF. PDF, as I said, is a probability density function. And sometimes all of these functions, we simply call them distributions as well. Okay? Distributions basically trying to tell you something about the spread of the data. Okay? So the most common PDF that you know is the normal distribution, right? This is like a bell shape, and it has some very nice properties. This distribution is very widely studied, and so on. You must have studied this in probability theory as well as in statistics. किसी की आवाज आई थी, कोई क्वेश्चन है? All right, no question. All right. Uh, if you have a distribution, you can also find skew or visualize skew. Skew actually is a technical uh, terminology which shows or which quantifies the amount of uh, non-symmetry of your distribution. So, so for example, maybe your distribution is skewed towards the right. You can say the distribution is skewed to the right, maybe skewed to the left. It might be symmetric. There's no skew. So you can get an idea of the skew from the distribution, from the histogram, from the PDF, and so on. So, but there are some statistical measures for computing skew as well, but they are not that relevant or much relevant in data mining. But you can use them. Usually, it will be sufficient to just look at the data in a distribution plot and get an idea of the skew. Of course, the normal distribution is unskewed. It is symmetric. It's not asymmetric. All right. Uh, Now let's move on to trying to understand two attributes at a time, or characterizing two attributes. Um, okay, before I start that, let me just give you a notation. I think I didn't do this last time. So the most common form of representation that we are talking about is the tabular representation. Okay? So which is also in math a data matrix. So columns are attributes, rows are observations. All right. ठीक है? So in we can often represent attributes as A, B, C, D, and so on. ठीक है? So that's we can represent attributes with capital letters, or we can define a combined matrix notation for the data matrix. So for example, one observation. So for example, xi, the underscore basically means a subscript. So this is a vector. So this is a vector. So vector would contain values x I1, x I2, x IM. ठीक है? So we have m attributes. So in total, so these are the columns. We can represent those columns as A, B, C, D as well sometimes, but if you want to use math notation, I will use the second subscript for the column. So for example, x3 2 5. So this is the fifth attribute value of the second observation. ठीक है? ठीक है? So in this way you can have the entire data matrix. So first subscript is the row, the second subscript is the column, second subscript is the attribute, the first subscript is the observation. Okay? And if we talk about one row as a whole, vector as well as a matrix, we represent it as in bold. So sometimes मैं bold लिखूंगा नहीं, but I think you will understand from the context that this is bold. So for example, xi, so this is an entire row, the ith row. ठीक है? And the whole data matrix would be the capital X. The complete data matrix. ठीक है? All right. So now let's go back to our two attributes. So we would like to understand the relationship between two attributes in our data set. Now the two attributes can be various combinations. So we talked about two primary types of attributes, numeric and categorical. So the two could be numeric, and then you can have numeric, categorical. ठीक है?
Sir, I have a question.
जी जी पूछें.
जी सर, अभी आपने सॉरी मैं थोड़ा सा पीछे की बात कर रहा हूँ, आपने x_i की बात की, तो यहाँ हम एज्यूम कर रहे हैं कि जो i है और जो एट्रीब्यूट्स हैं वो यूनिट्स में है, तो हम किस तरह डिफरेंशिएट करेंगे कि अगर फॉर एग्जांपल नंबर ऑफ डिजिट्स i के और m के मोर देन 1 हुए या फिर अनइवन हुए, देन हाउ डू वी नो कि कौन से आखिरी वाले एट्रीब्यूट्स हैं और कौन सी रोज हैं?
Generally when we represented as a data matrix, so हम रो फिक्स कर लेते हैं कि पहला रो जो होगा वो मतलब या रो और कॉलम फिक्स होते हैं हमारे पास. So first column for example represent a particular attribute, let's say age. The second column represent, let's say, weight. The third column, this would remain throughout fixed in the analysis. तो वो
जी
फिक्स कर
लेकिन
लेते हैं.
मैं ये बात कर रहा हूँ फॉर एग्जांपल हमने 25th रो निकालनी है ऑफ सेकंड एट्रीब्यूट, तो इसका 252 होगा, लेकिन हाउ
अच्छा
डू आई नो कि 252 के अंदर एट्रीब्यूट कौन सा है और रो कौन सी है, क्योंकि वो
वो
अनइवन है,
उसका
मुझे नहीं
आप
पता
डबल
लगेगा।
डिजिट्स में जा रहे हैं तो वो तो फिर आप लेट्स से कॉमा डाल देंगे ना उसमें. आई
अच्छा
डिडंट
ठीक है,
उसमें मैं सिंगल डिजिट्स में कर रहा था तो वो इजियर था आपको. सो यू आर टॉकिंग अबाउट के लेट्स से x, so let's say 25th रो है and let's say 100th एट्रीब्यूट है. ठीक है? तो जनरली फिर हम कॉमा डालेंगे यहाँ.
ऑलराइट सर, ठीक है, थैंक यू।
ठीक है? सबस्क्रिप्ट में भी कॉमा होगा जस्ट टू डिस्टिंग्विश बिटवीन द टू. ठीक है? तो ऊपर इफ दे आर सिंगल डिजिट्स फॉर एक्सप्लेनेशन पर्पसेस वो कॉमा नहीं डाला हुआ था. सो दैट इज ऑफ कोर्स मिसलीडिंग. ठीक है? अच्छा. सो ठीक है, न्यूमेरिक कैटेगोरिकल हो गया. देन वी हैव कैट कैटेगोरिकल. तो आपके पास ये कॉम्बिनेशंस आ सकती हैं. You have both numeric, you have one numeric, one categorical, and both categorical. So let's look at some common measures for understanding these pairs of attributes. ठीक है? So if you talk about numeric, so how do you understand numeric? Let's say आपके पास weight है और let's say उसके बाद height है, let's say. ठीक है? So both of them numeric, both of them ratio scaled. ठीक है? इसमें जो मोस्ट कॉमन मेजर यूज होता है आपको सबको पता होगा, राइट? to find the relationship between two numeric attributes is basically our correlation. ठीक है, या कोवेरियंस, कोवेरियंस कर लेते हैं पहले. ठीक है, कोवेरियंस. बाय द वे, फॉर सिंगल एट्रीब्यूट्स वी हैव वेरिएंस. वो शायद मैंने ऊपर मेंशन किया था, आई डिडंट मेंशन इट. स्प्रेड के लिए वो, बट फॉर सिंगल एट्रीब्यूट्स वी यूज वेरिएंस. ठीक है. So covariance of a distribution, of course, is expectation of the difference of the value from its mean square. ठीक है, square of the difference between the value and its mean. But of course यहाँ हम data mining की बात कर रहे हैं, observational analysis की बात कर रहे हैं. We will be talking about sample uh, statistics, not statistics over the distribution. So sample statistics की बात हो रही है. तो how do you find the covariance? So let's say covariance of uh, so attribute, let's say 1 या attribute I and j. ठीक है. So you can compute this by 1 divided by n minus 1. This minus 1, n minus 1, of course, comes from statistics, unbiased estimator. So we have the big sigma, right? Summation. So summation would go over I, so number of observations, is equal to 1. उसका upper limit होगी वो n है, number of observations. ठीक है. Just a second. Yeah, that's fine. ठीक है. So I and j actually वहाँ हम use कर रहे हैं पीछे. So these are the two attributes that we are using. So इसको फिर मैं यहाँ कुछ और use कर लेता हूँ. K use कर लिया मैंने. So essentially then we have this summation here, x ki minus m k into x k j minus m k. ठीक है. So what is m? k नहीं है ये, ये k ही है. एट्रीब्यूट ये कौन सा था? j है. ठीक है. All right. So notation का थोड़ा सा issue, but you know this formula. So what is mi? So mean of attribute I, and similarly mj is the mean of attribute j. ठीक है. So this would give you the sample covariance, and this way covariance would be, can be negative, can be positive. So a positive covariance means that these two attributes are positively correlated, meaning that if one increases, the other also increase. So in this particular example, usually height would also increase in general with weight. So these would be positively correlated. Of course, if this value is negative, then it means that as one value increases, the other decreases. Okay, so this is a measure that is used, sometimes also called the Pearson correlation. But this is not actually, this is covariance. If you divide covariance with the standard deviation, so covariance ij divided by the standard deviation std of I and the std of j. So this is actually your correlation. ठीक है. So correlation is actually the normalized covariance. Now this value would range between -1 and 1. So covariance का negative ज़्यादा भी हो सकता है, positive भी ज़्यादा हो सकता है. But if you divide by the respective standard deviations, uh, then this would be normalized and it becomes correlation. ठीक है. So this is the common way of understanding two numeric attributes. There might be other measures as well, but this is the most common and more than enough for most analysis. If you have a correlation or covariance of 0, so we say that they are uncorrelated. So that does not mean the causal concept of independence. So uncorrelation generally does not mean independence. Of course, if something is independent, or if two attributes are independent and you know that from uh, additional information, then for sure their correlation would be 0. But if you find that the correlation is 0, it does not necessarily mean that they are independent. All right. So now this was numeric attributes. So what about if both are categorical? Categorical. So let's say uh, you have, so for example, job roles, and then you have gender, for example. So both of these are categorical attributes. How do you understand the relationship between them? So for this, you typically have to create a what is known as a cross table, cross tab. Okay. So let's do that. So so let me say we have gender male and female and roles हम ले लेते हैं, दो roles ले लेते हैं कोई uh, basically engineer and doctor ले लेते हैं. I think typical Pakistani scenario. Of course each attribute की value multiple भी हो सकती है, दो से ज़्यादा भी हो सकती है. This would still work. So let's say so मेरे rows में male and female है और columns में पहले मैं doctor ले लेता हूँ और फिर मैं ले लेता हूँ engineer. ठीक है. So what we need to do is we need to fill out this cross tab from our observed data. So this first cell would mean how many males are doctors in our data. So let's say, just to take an example, let's say this is 50. The second is how many engineers are male. Okay, how many males are engineers? So let's say this is let's say 100 kar deta hu. Now we are talking about females. So how many females are doctors? Let's say 75. And how many females are engineers? Let's say 50 here. ठीक है ना? So you can, these are counts actually, the number of observations that have this characteristic. Remember we are talking about two columns, two attributes, both of them categorical. और count हम data set में कर रहे हैं कितने male हैं D, कितने male हैं E, कितने female हैं D, कितने female हैं E. And from here you can develop various statistics. The one that we are going to quickly look at is the chi-square statistics. ठीक है? Which would quantify the relationship between these two attributes. ठीक है? So these, ये क्या हुआ? Write the sums as well. 150 here. So these are the row sums, which are all males, all females. So females are 125, males are 150. And the column sum भी मैं यहाँ लिख लेता हूँ. So we have 50 for doctors and 75. तो 125 आ गया इधर, और 100 और क्या था, and 150. ठीक है. So total क्या होगा, 150 plus 125, 250, 275. ठीक है. So n is equal to 275. All right. So chi square basically computes the deviation of the values from the expected value, and the expected value is based on the assumption that each attribute is independent of the other. ठीक है. और वो हम compute कर सकते हैं from the total sum by taking a cross uh, of the total values. So for example, so these are 50 is the observed number of males that are doctors. ठीक है. अब parenthesis में मैं expected लिख रहा हूँ, which is based on the notion of independence. ठीक है. So how many males do we have? We have 150 males, right? So we have 150 males. How many doctors do we have? We have doctors हमारे पास थे 125 शायद, 50 and 75, yeah, 125. ठीक है. So we can compute this value by simply taking the cross product of 150 into 125 divided by total 275. So 68 is the expected value uh, if they are assumed to be independent. ठीक है. So ये value आ गई. अब हमने जो chi-square, of course this is computed for each cell. There are 4 cells here, and then we simply add the difference in the chi-square stat. So chi-square stat क्या होगा? For the first cell, so basically it's 50 minus क्या था, 68 था, 68 uh, 68 0.1 square divided by the expected value which was 68.1. तो ये पहले सेल की एक हमारे पास डिविएशन आ गई है. इसी तरह बाकी सेलों के भी हम करते जाएंगे. ऑब्जर्व्ड माइनस एक्सपेक्टेड स्क्वायर डिवाइडेड बाय ई प्लस तीसरे सेल की डैश 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 प्लस चौथे सेल की. So this would give us our chi-square, and this is going to be a number that is always greater than 0. So chi-square is always greater than 0. Larger the number, what does that mean? The two attributes are strongly correlated or highly correlated. If the number is close to 0, it means that the observed value and the expected value are the same. So if they are the same, if you look at the numerator, O minus E would be 0. And if you sum all zeros, that would give you a 0. That is the ideal scenario when both attributes are independent. But when they are not independent, this value would increase. The higher the value, the more they are related. In statistics, of course, you can define a threshold, or you can find a threshold at which you can state whether these attributes are related with a certain degree of confidence. So in most data mining, you don't really need that. Uh, Simply you need to look at the value. The higher the value, then it means that it's related. Smaller the values mean that it's less related. ठीक है. So this is the chi-square. Of course, there are other measures as well. I'm telling you the most typical measures which are commonly used in data science. So chi-square for cat-cat and uh, correlation and covariance for numeric. Um, all right. Any questions?
यस सर, आई डू हैव वन। सर मुझे वैसे एसेंशियली ख़ास समझ लगी नहीं कि एक हम लोग जो कोरिलेशन है वो किन चीज़ों के बारे में निकाल रहे हैं, लाइक जो 68.18 हमारे पास मेट्रिक निकला है, व्हाट डज़ इट सिग्निफाई, व्हाट डज़ द एक्सपेक्टेशन ऑफ दिस वैल्यू मीन, लाइक इसका मतलब क्या है?
एक्सपेक्टेशन वेरियस हो सकती हैं. कुछ हम अभी थोड़ी देर बाद भी डिस्कस करेंगे. It depends on your problem domain. One expectation, for example, could be if two attributes are very strongly correlated, let's say, and both of these attributes are like input attributes to your analysis, then you might consider dropping one. Meaning that both attributes convey the same information, they are strongly related. एक बढ़ता है दूसरा भी बढ़ रहा है, तो maybe you just need one of those attributes and not both of them. ठीक है. एक तो ये चीज. दूसरा ये कि this can also be used to detect issues in your data. For example, maybe two attributes that are coming from two different sources, they may have different names, but they may actually be the same thing. तो उसका जब आप correlation निकालेंगे, ये relationship निकालेंगे, if that is high, it means that they might be duplicate. Maybe एक customer database से आ रहा है, एक sales का database, एक marketing का database से आ रहा है, but they may be the same thing. So if you have a strong correlation, it means they might be duplicates. You need to investigate that further. तो मतलब इसकी several interpretations हैं. They often depend on what you're trying to do. तो हम जब exploratory data analysis कर रहे हैं, जो हम यहाँ generally discuss कर रहे हैं, वो यही है कि trying to just get a better idea of the process that is generating the data, and then from that understanding related to our ultimate goal. तो हमारी are these both of these important to us? Are these both of them may be redundant? एक duplicate तो नहीं है, and other things. तो इस तरह की हम insights लेना चाहेंगे.
राइट। एक और सवाल था, मैंने बस कंफर्म करना था, जो आपने 68.18 वैल्यू निकाली है, essentially what you've done is कि you've multiplied the sum of individual rows and then you divided them with the sum of columns. ऐसे
किसकी
है?
बात कर रहे हैं, जो covariance की?
जो आपने जो 68.18 जो वैल्यू निकाली है, मैं
हाँ
इसकी बात कर
हाँ
रहा
जी,
हूँ
हाँ
कि
जी.
ये आपने यही
Exactly.
किया
You
ना?
multiplied the sum of row with the sum of column and divide that with the total number of observations, which is
ऑलराइट, ठीक है,
275.
थैंक यू।
Okay. So this is almost similar like जैसे आपने databases में पढ़ा होगा, जब आप so उसमें एक ऑपरेटर होता है, वो जो ज्वाइन का ऑपरेटर होता है, नाम मुझे एग्जैक्ट भूल गया, आउटर ज्वाइन कहते हैं, क्या कहते हैं उसको. तो वेयर यू डुप्लीकेट ईच रो ऑफ वन विद एवरी रो ऑफ द अदर, तो दिस विल मेक इट इंडिपेंडेंट. अब इसमें हम ये क्या कर रहे हैं, हमारे पास कितने मेल्स थे, 150 मेल्स थे, और हमारे पास कितने डॉक्टर्स थे, 125 डॉक्टर्स थे. तो हमने इंस्टेड ऑफ वी सेड दैट फॉर ईच मेल हमने सारे डॉक्टर्स लगा दिए. ठीक है. So in other words, we are our new data set which is independent means that it has 150 times 125 observations. उसको पे 275 से डिवाइड किया, तो ये हमारे पास expected value आ गई for this cell.
ऑलराइट सर, थैंक यू।
ठीक है. All right. So we have talked about numeric. We have talked about categorical. One other case is remaining, which is categorical numeric. ठीक है. अब इसमें क्या सिनेरियो हो सकता है, इसमें लेट्स से कैटेगोरिकल में लेट्स से मैं जेंडर कर लेता हूँ. you can use the same. ठीक है, तो कैटेगोरिकल में जेंडर कर लेता हूँ, लेट्स से न्यूमेरिक में मैं लेट्स से इनकम कर लेता हूँ, ठीक है। अब इसका किस तरह रिलेशनशिप निकालेंगे, इसमें यू कैन कंप्यूट एंट्रोपी फॉर एग्जांपल, जो म्यूचुअल इंफॉर्मेशन होती है। यू कैन आल्सो कंप्यूट सम अदर मेजर्स। एंट्रोपी ऑफ कोर्स आप निकाल सकते हैं, विच विल डिस्कस द फार्मूला लेटर ऑन एज वेल। यहाँ मैं एक और मेजर बताऊंगा विच इज आल्सो वेरी सिमिलर टू एंट्रोपी, और ऑफ कोर्स इट हैज़ अ रिलेशनशिप टू मशीन लर्निंग। वो रिलेशनशिप यहाँ इंपॉर्टेंट नहीं है, हम यहाँ सिर्फ uh, uh, एक रिलेशनशिप बिटवीन टू एट्रीब्यूट्स निकालने के लिए यूज कर रहे हैं। सो दिस बेसिकली इज एरिया अंडर द ROC कर्व, ठीक है। This stat is typically used for evaluating classification, binary classification algorithms. बाइनरी क्लासिफिकेशन में क्या होता है कि आपके पास जो आउटपुट होता है वो कैटेगोरिकल होता है, ठीक है ना, और जो आपके पास एक एट्रीब्यूट जो लेबल होता है वो कैटेगोरिकल होता है, और जो आपका मॉडल का आउटपुट होता है वो कंटिन्यूस होता है, यूजली प्रोबेबिलिटी या कोई स्कोर होता है। स्कोर इज न्यूमेरिक एंड योर क्लास लेबल इज कैटेगोरिकल, इसलिए वहाँ ये यूज़ करते हैं फॉर डिटर्मिनिंग द परफॉर्मेंस ऑफ द क्लासिफायर। यहाँ हम सिंपली यूज़ कर रहे हैं टू डिटर्मिन द रिलेशनशिप बिटवीन ए न्यूमेरिक एट्रीब्यूट एंड ए कैटेगोरिकल एट्रीब्यूट, ठीक है। सो इसका यू कैन डू इट रियली स्ट्रेट फॉरवर्ड, मैं एग्जांपल से दिखा देता हूँ। लेट्स से आपके पास डेटा सेट है जेंडर और इनकम का, तो लेट्स ले लेते हैं कुछ तो बना लेते हैं छोटा सा डेटा सेट। सो लेट्स से मेल जेंडर है, और and of course data set would be in some order of income, but let me write it in order of sorted income. आप sort तो कर सकते हैं based on income. So let's say 50-50 के let's say is K, ठीक है। So let's say female आ गई, let's say 80 K, 80, ठीक है। And then we have another female, let's say uh, maybe 90. Let's say we have male 100. Let's say we have female 120, and then we have male 150, ठीक है। I've sorted the data. Of course, in your original database, it might not be sorted. You have to sort it. This is a requirement for applying the AUC. So, so we have the sorted order of genders is what? M. So there are one M, there are two Fs, then there is another M, then there is a F, and there is a M. So मैं इसको sort में लिखूंगा तो you have M, F, F, M, F, and M. So total हमारे पास कितने हैं M? तो तीन तीन है एक्चुअली, राइट। 6 हमारे पास टोटल वैल्यूज हैं। So the way to compute this is you simply start from one end and choose one of the values as the anchor value, or although you can flip it as well, complementary answer आएगा। So let me take M as anchor value, ठीक है। तो ये पहला मेरा M है, ठीक है। So M के पीछे कितने M हैं? Of course 0 है, ठीक है। Now look at F, F के पीछे कितने M हैं? 1। So मेरे पास पहला 0 आया, फिर 1 आया, फिर दूसरा F के पीछे कितना M है? Another 1, ठीक है, ठीक है। तो देन वी हैव एन M, उसके पीछे कितने M है? Another 1, ठीक है। एंड देन वी हैव एन F शायद, उस F के पीछे कितने M है? A 2, ठीक है। एंड देन फाइनली वी हैव एन M, उसके पीछे कितने M है हमारे पास? Another 2। ये क्या होगा? हाँ ठीक है, ठीक है. So do you get this? तो denominator में we divide it by the number of males and the number of females. One आसान चाहिए. Okay, just a second. Denominator में 3 times 3 9.
फिर न्यूमिनेटर में 7 होगा, वो 1 + 2 होना था.
जी.
तो यहाँ पे 12 लिखा गया, वो 1 + 2 होना था, तो आंसर
12 लिखा गया,
0.778.
सही है, ठीक है. ये कितनी वैल्यूज होगी? 6.
यस सर.
So you get a value of 0.7. So AUC typically ranges between 0 and 1. ठीक है? And a value of 0.5 means no relation. Or you can say, of course, you can't say independent, but no relation. And a value that's close to 1 means strong relation, and a value close to 0 on the flip side is strong relation. So I said that you get complementary results. In this computation here, I had used M as the anchor. If you had used F as the anchor and did the same computation, you would get a value on the other side. ये 0.7 आया था ना, वो आपके
यस सर.
पास complementary 0.23 आएगा, कुछ इस तरह की वैल्यू होगी, या पॉइंट आई डोंट नो पॉइंट या 0.2723. ठीक है? Which means that these two attributes are related. Of course they are not, they are related, fairly strongly related. 0.5 के करीब होता तो ये नहीं होता. आप ऊपर देख भी सकते हैं. So you see that males tend to have lower incomes than females tend to have lower incomes than males. So you can determine the gender of a attribute by looking at the income. So if they were totally random, let's say एक m के बाद f आ जाता, फिर m के बाद f आ जाता, m के बाद f आ जाता in the sorted list, तो ये 0.5 के करीब आना था. पर यहाँ आपको देख रहे हैं कि f थोड़े से ऊपर आ रहे हैं, m थोड़े से ज़्यादा नीचे आ रहे हैं. तो you get a relationship. ठीक है? So you can use this. Of course, you can also use entropy as well. Cross entropy भी कह सकते हैं, या entropy simply कह सकते हैं, या mutual information. Mutual information is also entropy. Of course, if you use entropy or mutual information, इसमें जो zero की value है, it means that they are related, strongly related. Higher values mean that they are, sorry, zero की value का मतलब ये है, yes, zero का value का they are related, and higher values के मतलब they are unrelated. Basically, zero means they are homogeneous, and higher values mean they are inhomogeneous. Okay, so these are about relationships between two attributes. And then, of course, you can plot them and visualize them as well. So plots could be various. You can use a scatter plot. All of you are familiar with scatter plot. Scatter plot is most appropriate if both attributes are numeric. तो आप एक point plot कर सकते हैं. So उधर से आपको relationships भी नजर आ जाएंगे. They are positive correlated, negative correlated, and so on. ठीक है? You can also use a QQ plot, quantile plot. दोनों तरफ quantiles हैं, दोनों attributes के. Remember last class में हमने सिर्फ एक axis पे quantile था, दूसरे पे value थी. So now in this case you have plotting the values for you're plotting the quantile for the same values for the entire data set. तो ये क्वांटाइल प्लॉट से भी आपको आइडिया हो जाएगा. तो ये कुछ फिगर्स दी हुई हैं स्लाइड्स में. Let me see. 25. So this is like a scatter plot, and you can get the trend as well. एक ऊपर वाला ट्रेंड जा रहा है, means that positively correlated, नीचे जा रहा है तो negatively correlated. If you just see a ball, uh, then they will be uncorrelated. Okay, so this is uncorrelated. So this is just points that are plotted on a scatter plot. So you can also do the QQ plot. This is kind of more difficult to understand, but it does give you a lot of information. So both axes पे आपके पास quantiles हैं, ठीक है. So let's say you're talking about uh, so ranking आपने देखनी है both attributes की, तो आपने हर ranking पे आपने उसकी value plot कर देनी है. You get a curve that gives you a distribution. And then in addition to this, you may have many other types of visualizations. तो वो हम डिटेल में डिस्कस नहीं करें. बुक्स में कुछ दिया वैसी चैप्टर में एंड पे, बट सम ऑफ दोज आर नॉट वेरी पॉपुलर एक्चुअली. एक दो ही हैं पॉपुलर, सो बट आई वोंट डिस्कस दैट इन क्लास. आप क्विकली अपनी रीडिंग में ही देख सकते हैं. The whole idea here is that we want to use graphs, we want to use plots and other ways of trying to understand our data better. And through understanding our data, we want to understand our data generating process. The domain understanding, data understanding का काम चल रहा है अभी, ठीक है. All right, so let's move on. So the next main topic is data preprocessing. So this would be chapter 3 of your book by Camber, Han, and also I think corresponding chapters in the other textbooks. Uh, so data preprocessing are actually a lot of things. So we will cover these things by categorizing them and then looking at some of the techniques in each of those categories. But the point to remember is that for any given task, for any given data mining project, you are not required or you would not be using all of them. The whole idea of discussing this is to give you an idea कि क्या चीज़ें available हैं और उनको कब apply कर सकते हैं, उसका impact क्या होता है, effect क्या होता है, and so on. ठीक है. So let me give you the categories that are used in the textbook by Han, and then we will discuss some other things. So the categories are basically data cleaning. Okay. Then we have integration. So essentially trying to merge two data sources. And then we have what is known as reduction. Reduction is essentially concerned with reducing the size of data. And then we have generally normalization is another category. And then finally discretization. So these are categories of techniques that can be used during the data preprocessing process. And within each category, there may be other techniques, smaller techniques that you can apply. Okay. So first of all, just a few things. So data preprocessing is usually donkey's work, meaning that you have to do a lot of work, but it's a reality. I worked in the industry as well, uh, consulted for the industry as well. So I think most of the time, data scientists or data engineers spend their time on data preprocessing. So it's dirty work, but it's lot of work. So people have estimated that for any project, you can spend like 70 to 80% of time on data preprocessing. So these are estimates that are typical for most industry projects. Okay. So, and the whole idea of data preprocessing is to ensure that your data is of higher quality, becomes of higher quality and is relevant or becomes relevant for your particular application. ठीक है? लेट्स से बाद में आपने लेट्स से कोई क्लासिफिकेशन मॉडल रन करना है तो उसके लिए आपने 70 to 80% टाइम पहले ही गुजार लिया डेटा को शेप करने में, प्री प्रोसेस करने में। बाद में आपके पास 30 to 20% जो टाइम है वो सिर्फ क्लासिफिकेशन मॉडल्स हैं और उसकी इवेल्युएशन है। So in the real world, you would probably never ever find data that is of the desired qualities. You still have to spend some time fixing the data. Okay. Uh, and if you recall the data mining process that we talked about earlier, so this corresponds to the early phase of data mining process. जब आपको data sources से data lake या data warehouse तक data आता है, तो इस process को sometimes people also call the extraction, transformation and loading for the case of data warehousing. Yeah, we call it extraction loading into the data lake and then transformation before applying the final data mining technique, ELT or ETL. So this is for data lake. So this is for so extraction from the source, transformation. So all of those things that we talked about essentially are transformations. ठीक है? आप रिडक्शन कर रहे हैं तो आप डेटा को ट्रांसफॉर्म कर रहे हैं, आप डिस्क्रिटाइजेशन कर रहे हैं, आप डेटा को ट्रांसफॉर्म कर रहे हैं, आप क्लीनिंग कर रहे हैं, यू विल बी डूइंग ट्रांसफॉर्मेशन। ठीक है? ऑल ऑफ दैट इज ट्रांसफॉर्मेशन एंड देन ऑफ कोर्स लोडिंग into your final repository. ठीक है? So we are kind of running out of time. So let me just introduce data cleaning. Any questions, by the way? Maybe I think let me start with the quality. अच्छा वो खुली भी नहीं है, अच्छा सही है। Okay. Uh, so I think we will continue with our online mode unless there is a strong urge from you guys again to reverse that order कि आपने ऑन कैंपस ही करना है। टाइम अवेलेबल, मैं ये लेक्चर भी ऑन कैंपस ही दे रहा हूँ, ऑफिस से दे रहा हूँ। So we did a poll, so 51% people said that online is better, 41 said on campus is better. So we are doing this online. So if there is a strong urge that I should go back to on campus, so do let us know and we will move it to on campus again. But right now it is on campus, online. So आज का lecture जैसे online था, recording भी हो रही है, I will upload it later on, and then Thursdays का lecture भी hopefully online ही होगा। By the way, Thursday को आपका quiz भी है। So quiz भी would be in class, no online quiz. So आपने क्लास में बैठना है और end of the class around this time 3:05 p.m. आपका quiz start होगा. It would be pen and paper, no notes, no books. ठीक है. और quizzes मेरे typically इस तरह ही होते हैं कि you have short questions, you will have about 3 to 4 questions. Maybe एक question MCQ भी हो सकता है, but most questions will be short questions. Short questions में I typically don't ask definitions. So I might ask you to do something. Maybe कोई छोटा सा set है, उस पे कुछ आपने stat निकालना है या कुछ अपना assessment देनी है या कुछ और चीज़ बतानी है, depending on what we have covered so far. So we have only covered statistics and introduction and this material so far. So उसके बारे में कुछ question पूछा जा सकता है. ठीक है. Uh, So you'll need your pen and your paper and a calculator and nothing else. ठीक है? Anything else? Any other question?
सर
जी
सर ये आप जो आपने अभी नोट्स बनाए थे वो अपलोड करेंगे जी?
जी मैं कर दूंगा इंशाल्लाह जी.
थैंक यू.
अच्छा चलें फिर मेरे ख्याल से आज का लेसन ऑफ करते हैं. ओके